Let us recall the definition of derivative. So the definition is like this. If f prime x is defined as limit h tend to 0, f of x plus h minus fx by h. Now if this limit of this one exists, then we say that the derivative of function exists. Now this is the definition, and it is also known as method of first principle. So using this method of first principle, let us find out the derivative of 1 by square root of x. So first step, what you need to do is take fx is equal to 1 by root x. Then what is fx plus h? You replace x by x plus h, then you'll get it as 1 by square root of x plus h. Now f prime of x by definition, it is limit h tend to 0, f of x plus h minus fx by h. Now here you replace the value of fx plus h by this one, and then fx by square root of by 1 upon square root of x. Then f prime x now become limit h tend to 0, 1 by square root of x plus h minus 1 by root x upon h. And this will imply that f prime x is equal to limit h tend to 0, 1 by 1 plus x to the power half minus x 1 by x to the power half whole thing divided by h. Because square root of x plus h is same as 1, please correct this one, it is x plus h plus x to the power half. So now here if you bring this one to the numerator, then the power of this one will become minus. So it becomes limit h tend to 0, x plus h minus to the power minus half minus x to the power minus half divided by, now here we have the original one is h only, but now you add and subtract by x. Then you can write it as x plus h minus x. So this is equal to limit x plus h tend to x, because h tends to 0 will imply that h plus x will tends to x. Because h tends to 0, x tends to x itself, so h plus x will tends to x. So you can change that limit. Now it is x plus h to the power minus half minus x power minus half divided by x plus h minus x. And the formula for this one, now you can see that this one is of the form limit x tends to a, x to the power n minus a to the power n by x minus a, which is equal to na to the power n minus 1. Here what we have now, x plus h is of the form x, and then a is x only, and here you see that x plus h is that x and a is x. So the power here instead of n, it is minus half. So by applying this formula, it is na to power n minus half, a is x only, and n is equal to minus half. Then the value of this derivative is finally is equal to 1 by 2x power 3 by 2. Now let us come to the next problem. Find the derivative of sine root x with respect to x by method of first principle. So take fx is equal to sine root x, then what is fx plus h? It will be sine of square root of x plus h. So replace x by x plus h. Now what is f prime of x by definition? It is limit h tend to 0, sine of square root of x plus h minus root x, sine root x by h. This is equal to limit h tend to 0, 2 cos of square root of x plus h plus root x by 2 sine of square root of x plus h minus root x by 2. Now since this one is of the form sine a minus sine b, which is equal to 2 cos of a plus b by 2 into sine of a minus b by 2. So by applying this formula where a is square root of x plus h and b is equal to square root of x, we are getting the value of this one is equal to this. Now next step, this is equal to limit h tend to 0, 2 cos of square root of x plus h plus root x by 2. This will remain as it is. Now sine here, inside the sine function, you introduce this term. Square root of x plus h minus root x by 2 remain as it is. Now multiply and divide by square root by the conjugate of this one. Square root of x plus h plus root x by square root of x plus h plus root x. This and this can be cancelled. It will be 1, so it will remain the original one only. So now this one is of the form a minus b into a plus b. We know the formula a minus b into a plus b will be a square minus b square. Now it will be x plus h, square root of x plus h the whole square minus root x the whole square. Square root sign will vanish, so you will get x plus h minus that one x divided by 2 times of square root of x plus h plus root x. On simplifying this one, x and x will be cancelled, so it remained here. This term here, first term will remain as it is. Then sine of h by 2 into square root of x plus h plus root x. So this is equal to limit h tend to 0, 2 cos of root x plus h plus root x by 2 into sine of h by, this will remain as it is, 2 into square root of x plus h plus root x by h. Because a into b by c is same as a into b by c. So you can write this h as a divisor of this one by applying this rule. So this is equal to 2 cos root x plus h plus root x by 2 as it is. So sine h by 2 into the same thing. But now here you divide the denominator by 2 into square root of x plus h plus root x. And then you have to multiply the numerator also by that one, because this term and this will be cancelled. So it will remain the original one. So now you see that this is equal to limit h tend to 0 cos of root x plus h plus root x by 2. Now this term here, you can bring it to the denominator of this cos here. So it will be square root of x plus h plus root x into sine of h by 2 into square root of x plus h plus root x by h upon 2 into square root of x plus h plus root x. Now this one you can take as limit h tend to 0 of the first term into limit h tend to 0 of the second term. Now the second term is of this form. Limit theta tend to 0 sine theta by theta. So this one is of that form only, because theta will act as this one. This is theta. So sine theta by theta, as theta tend to 0, the value is equal to 1. This is a standard limit. Then here the value of this whole thing of the second term will be 1. Now here you can replace h by 0 in the first term, because the denominator will never be equal to 0. So after substituting the value of h by 0, so finally the derivative of sine of root x become cos of root x by 2 root x. Hope with this explanation now it is clear how to find the derivatives of a given function by method of first principle or the definition.